So, welcome very much to the second Raspberry Pi Foundation Computing Education Research Seminar. We're really delighted that you're able to join us today. We're running these every 2 weeks until the end of July, and then we're having a break in August, and then we plan to, these seem to be going quite well, so we plan to carry on in September. I'm delighted to welcome our speaker all the way from Spain. Isn't online wonderful? We can have speakers from all over the world and all the way from Spain, who's from, and Diane's kindly translated it for me, the National Institute of Educational Technologies and Teacher Training, to save me having to say all that in Spanish. And his topic of his talk is Learning AI at School with Scratch and LearningML. So without further ado, let's all welcome Jazz Hands, Juan David, and you can take over from sharing the screen.
So, well, thank you very much for the presentation, Shu, and thank you to the organization for giving me this opportunity to present my work in this interesting initiative. I would like to thank also to all the people who are attending this seminar right now. Okay, so about a year ago, I started to explore the possibility of teaching and learning artificial intelligence at the school. Jesus Moreno, who was then my boss at INTEF, proposed me to work on an educational resource about artificial intelligence by using an awesome tool, which is called Machine Learning for Kids by Dave Lane from IBM. When I finished this work, I was fascinated, and I deeply felt that I wanted to explore this subject much more. So together with some member of key GBL3 research group, the doctors Jesus Moreno, Marco Román, y Gregorio Robles, I started to develop a new tool intended to teach and learn artificial intelligence. The result of this work will be the matter of this talk. Okay, this is the outline of the talk. First, I will give some reasons we think it's important to teach AI at the school. And second, I will give a very brief introduction to machine learning. And third, I will describe our tool, Learning Machine Learning, and how can it help us to teach and learn AI at the school. And finally, I will present some research we are carrying out around the tool. So let's start with the first point, some reasons to teach AI at the school. Okay, so we think that in a society highly dependent on digital technology, teaching the fundamental of computer science is a great strategy to help citizens learn these technologies efficiently. In this sense, artificial intelligence is one of the last computer science disciplines that is having a great impact in our society and in our digital society. Even though a lot of people are thinking yet that AI is a matter of science fiction novels or something exclusive of universities, research center, a big corporation, the reality is very different. We are all using daily, more or less consciously, applications which are based on artificial intelligence. Let's see some examples of them. For example, facial recognition, spam mail filters, conversational chatbots, computers playing, learning, and even winning a world champion of complex games such as Go and chess, self-driving cars, products recommendation systems, sentimental analysis, language translation and recognition, and many more applications that are based on artificial intelligence and are being used daily by millions of people. So the point is that AI is having a strong impact on society in all aspects of society, from economy to education, and will have even more impact in the future. So we think that it's a must that citizens know it's fundamental in order to understand what can be made with AI and how it can be affected to our lives. The ethical side, indeed, of this technology is an issue that should concern all of us. So we arrive to the second reason, and as a consequence of this, AI is a priority in the agendas of institutions and governments around the world. This slide shows, for example, 2 reports about the impact of AI in education. The first one has been developed by the joint research group of European Commission, and the second by the UNESCO. And in both reports, we can see that we can extract the conclusion that AI will change learning, teaching, and education in the next years. And well, the third reason we think is important to introduce artificial intelligence at the school is that AI, we think that practical AI activities can be added to programming and unplugged activity as a new and powerful instrument to foster computational thinking. Indeed, even more, some new concepts, practice, and perspectives coming from AI can be added as new dimensions to the classical Brain and Resnick city framework, as has been proposed, for example, by Jessica van Roemenen and others. These new dimensions will be classification, prediction, generation as concepts, training, validating, and testing as new practice, and evaluating as a new perspective. Okay, so we arrive to the second point. I'm trying to give a brief introduction to machine learning and artificial intelligence. Well, the first thing we have to clarify and to be very clear is that AI is more than machine learning. And a good way to illustrate this fact is by means of this drawing, which summarizes the artificial intelligence field into five big ideas. The first is that computers perceive the world using sensors. Second is that agents maintain representations of the world and use them for reasoning. Third, that computers can learn from data. Fourth, intelligent agents require many kinds of knowledge to interact naturally with humans. And the fifth reason is very, very important, and it is in the center of all of these big ideas, is that AI can impact society in both positive and negative ways. So, as you can see, one of the big ideas is that computers can learn from data. And here is where machine learning comes into play. Machine learning encompasses a range of techniques that allow computer to learn from data. And it has to be said that most of the current AI development is being carried out with machine learning. So it's frequent to say artificial intelligence when we really mean machine learning. Okay, then so what's machine learning? Well, we can solve lots of problems by coding in a traditional way. We look for the rules, underwriting the problem, and we implement them in a computer program. However, there are some problems which are very difficult to solve because we are not able to extract, to find the rules. Then, and this is the main idea, the key of the machine learning, when we don't have an algorithm able to be applied to our problem, but we have lots of data related with its solution, we can deal with the problem from another perspective. We can use this data to infer possible solutions, and this is the essence of machine learning. Let's see this with an example. Let's consider, for example, we want to recognize what digit corresponds to the numbers writing by hand by different people. Well, taking into account that the same digit has a similar but different shape depending on the people who write it, to find a set of rules able to solve this problem is a very difficult task. How then can we deal with this problem from a machine learning perspective? Well, what we do is, we gather a big set of examples taken from several people, for example, and we tag each handwritten number with the corresponding digit. That is, this is what is called to build a training data set. Afterward, we feed this data set to a machine learning algorithm that will use them to fit a model able to classify new handwriting numbers. In this picture, for example, the model is represented by the machine, while the genius represents the algorithm that is working hard at using the model parameters to be able to classify similar but different handwriting numbers. Then, once the machine learning algorithm has finished, the model is available. We can use this model in our application to develop an application. Then, when we introduce new handwriting numbers as input, the model will give us the corresponding digit and a percentage representing the confidence of being correct. These are probabilistic models, and so therefore they assign a probability to each of the possible answers. They are not perfect, they are not exact. But if you if you have a good training data set, the model will respond very fine. Okay, so we can talk about a new way to solve computing problems. The top box of this drawing shows the traditional programming way, while the bottom box illustrates the way problems are solved with machine learning. It is important to realize that once we have the rules induced by machine learning, we can use them to make a program in the traditional way. Here, I would like to point out that the bottom box provide us a new way to work and develop computational thinking skills, and it makes possible to introduce the new concepts, practice, and perspectives that I have said earlier in this talk. Okay. To end this section, I would like to point out that what I have shown is known as supervised machine learning. However, there are more types of machine learning. Anyway, beyond the details among these types, the main idea is that all of the machine learning techniques are based on data. The data provide the solution. Data is the key. Okay, so I'm going to describe our tool LearningML and how can it help us to learn machine learning and artificial intelligence contents. Okay, well, LearningML is a platform intended to teach and learn machine learning by doing. It has been designed on the principle of low floor, high ceiling, and wide walls. That is, it must be easy enough to start with. It must allow people to do better things if they want. And finally, it must support different interests and can be used in different situations. These principles have been used when developing successful programming platforms such as Scratch and Snap. So it's evident that we have also taken them to develop our tool. Okay, the tool has been designed to be used for children in the age 10 to 17, sorry. But we think that it can be also a good tool for undergraduate students and professionals who must understand ML fundamentals due to the new tools based on these technologies that are being introduced in their fields. Also, of course, anyone who wants to learn the fundamentals of machine learning in an easy and funny way can enjoy with LearningML, for sure. Our main goal when developing this tool has been to build a tool very easy to use. In this sense, you don't have to install anything in your computer because it's a web application and it runs completely in the browser. And also, registering is not required. This will speed up the time needed to try and make something useful with the tool. This is similar to Scratch. You can use Scratch without registering, but if you want to register in order to get more functionality, okay, you can register. In this tool, in our tool, it's the same. You can start using the tool without registering, but if you want, for example, to save your projects in the cloud and to share with other people, you can create an account as you want, when you want. Okay. So this platform is composed by 3 parts. First, we have the website where you can find documentation, activities, video tutorials, and other resources about the tool, and even for learning AI and ML. The second part, which is the main component of the platform, is the machine learning editor, which is you will use this editor to build, test, and image machine learning models. And finally, with the programming platform, the third part is the programming platform, where you can code video games or applications that use the model you have built with the machine learning editor. This is a modified version of Scratch where we are add some new blocks intended to make use of the ML model. Well, if you are interested in knowing more about the tool, you can read this article where we describe in depth LearningML. Well, we have reached to the demo time, so I'm going to drink a bit of water, and let's start. Okay, this is the website. I'm going to press the start button. Well, I have to say that the tool is writing in Spanish. We want to translate it to English in a short time, but right now it's only writing in Spanish. So, well, it's an inconvenience, but I hope this inconvenience will be overcome in the next time. Well, when I enter into the ML editor, I have 2 choices. I can to build a model, a text model, or I can to build an image model. Again, I have to say that if you want to build a text model, you have to do it in Spanish because the technology underlying text recognition, which is called natural language processing, is dependent on the language. Right now is implemented just in Spanish. This is order of the improvement we have to do to the tool. So I'm going to make a very quick model, image model. Now I press this button and I enter to the editor. I have 3 steps. We have 3 steps here. The first step is to train, where I'm going to gather the training data set. The second point, the second step is to learn, where the machine learning will use this data in order to build a model. And the third step is to test, where we can test if the model is working fine. Okay, I'm going to make a very simple image tool which will be able to classify pictures of myself with glasses, with a cap, without glasses, and with a cap. So I'm going to create 3 classes. The first class, for example, with glasses. Okay. The second class, for example, without glasses. And the third class, for example, with cap. Okay. Then I'm going to take some pictures of myself with a cap. I can use the file system with this button, but also I can take the photo directly from the webcam. So I wear my cap and I'm going to take some picture, 10 picture more or less. I'm moving my head in order to take different positions and different images of myself. Okay, I have some images with cap, now without glasses. So, okay, I'm going to take more or less 10 images. I move my head also for the same reason. And finally, I'm going to wear my sunglasses and well, I take again more or less 10 pictures. It's important that the number of data of pictures, in this case, in each of the classes will be similar, will be balanced in order to help the machine learning to work better. So now I have the training data set and I'm going to feed the machine learning algorithm pressing this button. Okay, now the computer is learning to recognize pictures similar but different to the ones I have taken right now. I have to say that this is a consuming time task. The learning process is a time-consuming task. But well, once we have the model works quickly. Now, the machine learning algorithm has finished, and now I can test the model. Again, then I'm going to use the third part. Again, I can upload a file from file system, but I'm going to use webcam. Okay, for example, I'm going to take another photo different from me. For example, myself with my hand in the head. And he said that is me without glasses. And here you have the probability, the confidence of being belonging to each of the classes. Okay. Now I'm going to wear my cap. Okay, and take another photo. I'm going to do something with my hand in order to take a photo different from the data set, from the training data set. And okay, it has been classified as me with cap. And here we have the confidence of each class. And finally, in order to see if the last class is working fine, I'm going to wear my sunglasses, and well, I'm going to put my profile like this, and okay, it says that it's an image of me with glasses. If I take a photo more similar to the training data set, probably the confidence will be higher. Let's go. Let's see. Okay, right? Now with glasses has a 97%. This is the building of machine learning. This is enough in order to foster computational thinking, but we can do even more. Now we have this model. We can code an application, a video game that uses the model. So in order to do that, I push the button, the scratch button, and a modification of Scratch is loaded. In this modification, we have added some blocks intending to use the model we have just built. These blocks allows to use text models. We can classify text based on the model to get the confidence for the test. And even we can add new text and run again the machine algorithms in order to get a better model. As I have made an image model, I have to use in order to code these blocks. And these blocks, again, can classify image to get the confidence for image, add a new image to a label, to a class, run again the machine algorithm, and so on. In order to go faster, I'm going to load for my computer a little program, a very simple program I have code for the demo. In this program is just this program has 4 blocks, 4, 5, 6 blocks. I have put these 3 customs of the Scratch cat, and the code when runs will turn the video on by using this block of learning machine learning. And I'm going to put this in English, sorry. In a forever loop, we'll be switching the costume in a loop depending of what will say the classification image block, the classified image block, apply it on the video image. Okay, so I'm going to run the program. The webcam is on. Okay, and now I'm going to wear my glass. The purpose of this program is that Scratch imitates me. Okay, so I put my sunglasses and Scratch is doing the same I'm doing. I wear my hat or my cap, and here Scratch is imitating me. Okay, so this is a quick demo in order to give us an idea, general idea of what you can do with this tool. We have to take into account that this is a programming platform, so the things you can do depends only of your imagination, because you can combine all the machine learning blocks with every Scratch blocks. Right? So you are in some way enriching, you are making richer the Scratch platform. Okay, so now I'm going to return to the demo. Okay. And in order to finish, I'm going quickly to show you some research we are doing with LearningML. Okay, so
sorry, 3 more minutes.
Okay, quickly. As simply to say that until now we have written and published 2 papers. The first one, we talk about the experience we have got when developing an educational resource and on artificial intelligence with machine learning for kids, while the second one describe in depth LearningML. So we have some first results. This slide shows these first results. The experience was performed with 14 participants, about 20 years old. They filled a pre-test, then an introduction about AI, which include the use of LearningML, was performed. And finally, the test was filled again. Then the answers were statistically analyzed, and 2 kinds of questions were asked. And in both cases, we found out a positive effect size. The results are reported in the second paper. And well, indeed, currently we are working on a new research where we intend to test the instructional and face validity of the tool. We want to know if people learn AI/ML and ML when using LearningML, and also if they find the tool engaging and easy to use. And in order to do that, well, as we cannot organize face-to-face events because of the current pandemic situation, we have planned an alternative online workshop workshop, which will be carried out from the 1st of June. Right now, we are promoting this online research. We are asking for collaboration to teachers, fathers, and mothers. A week ago, we made a live seminar on YouTube to present this initiative, and we hope to recruit enough volunteers to successfully perform this research. Here you have the URL where this online research is described, and of course, if you are interested in participating, we're happy to count with you, but well, the problem is that the research will be has been designed in Spanish. This is all. Thank you very much. I hope this talk has been of your interest, and I'll see you in the Q&A. Thank you.
That's excellent. Thank you very much. There's been lots of positive chat comments. Do you want to stop sharing your screen? There we are. Lots of chat going on. You'll be able to see that later, Juanda, or the comments about your talk. Thank you very much.
Okay, thank you. Thank you.
Now, so what we do now is we're going to divide everybody up in just a few minutes so they can think of some questions. I would suggest that when you get into your breakout groups, you think about what you each liked about the presentation and what a question that you want to ask. You have a whiteboard in your breakout group. What I forgot to say last time is that somebody needs to be in charge of the whiteboard and take responsibility for saving it before you lose it, and use the whiteboard to share your thoughts in the breakout groups. Diana, do you want to unmute? What have I forgotten? I got so excited about the glasses and the cap and everything. Are you ready to set everybody off?
That's perfect. Yeah.
Yep. Okay.
Yep, I'll do that now.
We'll see you soon, and we'll have a little chat. I'm just going to open the floor to did anyone manage to get a really good question and save their whiteboard and want to share, want to ask Juanda a question as well, apart from, can we have it translated into English, please?
Okay.
Would you want to, should we do it last time and just put your hand up? In the little reactions tab, there's a wave. It says clap, but if you use that to wave at me if you've got a question, like I'm doing my little wave there, and then I can ask you for your question, or you could put it in the chat. Otherwise I will, who's got a question? Oh, Duncan, your question, please.
Hi, Juan. That was excellent. Thank you very much.
Thank you.
Thoroughly enjoyable. And great that it's kind of, it makes it so immediately engaging. You know, I think that's the first takeaway. I think my question was, you know, at the end of the process, you know, you've created that machine learning model, and the kids can see what the model does because it gives input, and it gives you, you know, predicts what the output is going to be based on the way it's worked. How important is it that do you think that the people using this have some idea of what's going on inside that model? And the reason I asked is, in your early slide, there was a picture of machine learning, and then there was a picture of, you know, normal kind of programming and writing the algorithm, and it almost looked like your machine learning generated the rules that standard programming would like. And clearly, we know that's not what happens. You know, yeah. Where does that explanation of what's really going on fit?
Okay, so it's true. Now this tool just look the machine learning and the model as a black box. But in the first version, what we have tried to do is to show the 3 steps of supervised machine learning, no? And to put the relevance on the gathering of data, to show people, to show the student how important is to get a good training data set in order to train a model, okay? With the text model, for example, or even with the image model, you can see that if I put in the model trained another image that it's very different to the first one, the model doesn't work.
Yeah.
Okay, then we can explore right now, the fact that it's very important to gather a good set of data to train the model. With this is perhaps, well, the most basic things. Then we would like also to show some kind of image, of some kind of diagram, of some kind of simulation. I don't know yet very well, to show what is happening in there when the training process is being carried out.
Right.
But this is something that, it will be difficult because first, there are lots and lots of algorithms of machine learning, because machine learning is a family of algorithms. Then we are using an algorithm which is called the artificial neural network. That is the most common, the most known, and perhaps my idea, one of the ideas I have right now, is to show a picture of the neural network, and to see how the weight, the parameters of the model are changing while the algorithm machine learning is running.
Yeah.
Even we can also to show some some graphs that that show the evolution of some parameters important, but it's clear we have to center in a kind of algorithm. It's good. I would like to do this. Well, I don't know how many times I will spend in do that, but it's contemplated. Indeed, in the article we have written about machine learning, and which is referenced in the slide, we talk a little bit about this subject.
Okay, thank you very much. Yeah, that's
you.
good to know. Thank you.
Thank you.
I think that's a really good question. I think we all struggle with the idea of demonstrating something and then being at the technical level when you could actually, you know, implement something. Moving on to another question by George, which is a completely different topic. George, do you want to say your question, or shall I read it?
It's fine either way. I was curious about what's used underneath, and the whole process reminded me of both how we use machine learning for kids and also Google's Teachable Machine. So I was wondering what the common points are and what exactly is the underlying platform used in LearningML.
Okay, the underlying platform is TensorFlow. TensorFlow JS. The thing I have started to explore this world of artificial intelligence in the school. I started with machine learning for kids, and I was surprised. I was delighted with the tool, but where we see is that it is not very easy to make an account. There are some limitations due to you have to make an account in in machine learning for kids, but also in the cloud of IBM. And to create this account, it's easy for a software developer. For me, it was very easy, but it's not easier for a child. Even Dave Lane has a service personal. He's collecting emails that people send to him, and he creates this account. That I thought that was a problem. Of course, the cloud of IBM is one of the powerful tools to make machine learning. But I thought that this is for child. This is for learn the fundamental. We don't need the best platform to perform machine learning. And what we thought was it is possible to run the machine learning algorithm inside the browser. Not, I don't want to use any external tool, any cloud tool, any cloud service. I want to download the application to the browser, and the child or the student or whatever you want, it can use immediately the tool. So I discovered some libraries, some JavaScript libraries, and I started to study TensorFlow.js. TensorFlow.js is what I'm using. Like you have said, another platform, another
teachable
another
machine.
teachable machine.
Yeah.
It's
so the
very
difference
similar. Well,
yeah,
it's the same technology. Indeed.
The fact is that the teachable machine stops after you create the
Yes.
model, and you have to download it and use it separately, whereas you take that model and you use it in scratch. Yeah.
Yes, indeed, one of the idea I have is that when you build a model, you can save the TensorFlow model. And this TensorFlow model can be loaded directly from the Scratch platform. In this way, if you, for example, want to make a machine learning model with a teachable machine, you export this model and you can import in our platform. This is one of the idea in order to make compatible all these tools.
Okay, that sounds great. I think that was a good answer. Thank you very much. I've just got time for one more question. Just because I want to, in a different topic. Richard, you've put something about bias. Do you want to answer that question?
Yeah, that'd be good. No, I thought it was a brilliant presentation. It really got me, and I loved it. So it's very good from that point. The thing, one of my concerns about artificial intelligence, machine learning, is obviously the bias in the training data, and one of the learning points for the children has got to be what is bias and what can be in this bias. So you took your picture of you with your hat on, you with the glasses on, etc. And if Sue had done that, it wouldn't have recognized Sue because it was biased data. It was 100% male with beard. So it's just some way of actually pointing out to people using the tool that you have got a lot of bias in the data.
Yes, for example, an example that a clear example. Imagine, for example, an experience you can do with learning machine learning. Let's go to build a model which recognize cats and dogs. Okay, then you take a lot of picture of cats, a lot of picture of dogs, but you take among the cats, some of them are white, some are black, some are every color cats can have, no? But when you take the dogs, the set of dogs, there is not any black dog. Every dog has another color. Okay, then you train the model with this data set, cats and dogs. And once the model is built, you go to test the model, and you put a new image of a cat, white, for example. Okay, it's working fine. You put a black cat, okay, it's working fine. You put a white dog, it's working fine. You put a black dog, and the model says, this is a cat. No, because you have put as input a black dog, but the model says it's a cat. Why? This is something you can test. This is the bias. The data set, the training data set of dog is not very well because they had not any black dog. So it's a good way to show people, to show kids how this kind of algorithm can be biased, and this has a very ethical consequence, very hard, that we have to know as citizens This is the importance, for example, of learning machine learning and artificial intelligence at the school. It's one of the reasons, no, we think this kind of content must be learned at the school. Thank you.
That's great. Thank you. Thank you very much.
I was saying, I can think of a great visual there of a dog catcher going out, nabbing the wrong kind of animal, applying the algorithm, and kids completely getting that.
Yes, I have made the experiment.
Right.
I have made the experiment.
That's good. I think that's good that you're addressing that question, because I think it's really important. I'm really sorry it's gone 6 and we're trying to keep to time, and obviously we could go on with more questions, but I'm going to wrap it up there. So before I finish off, let's just give a big jazz hands or clap or whatever I can clap, because I've got my microphone not muted, for Juanda. And if you had questions that weren't covered, then I'm sure Juanda's Twitter handle is now on the screen. So if you want, I'm sure he won't mind if you bombard him on Twitter with questions. And we'd love for you to carry on the discussion on using our hashtag, so that we can, keep carrying on talking about these topics. We're going to share the slides. We will be sharing the video recording, and we will have a blog post coming out next week with some reflections on what we've been hearing, put together by myself with some input from Juanda. And also we have a feedback form, and we really like to, this is the second one we've done, we've got 7 in total and then some more in the autumn, but we really need your feedback, because we're taking note of all the feedback we get to try and improve the way we run them. Next time we've got Dame Celia Hoyles, professor from UCL London in maths education, coming to join us. She was on, you might have seen her sitting on her sofa earlier on but she's just had to go off and teach a class. She's talking about programming and mathematics and some of the research in maths education and how that impacts on the work we do, and talk about the UCL Scratch Maths project. Finally, there's a link to sign up for our newsletter that we send out periodically, with information about other things you might be interested in. So I think that's all my messages. I'm sure Diana will tell me if I've forgotten something. But thank you all for coming along. Really appreciated you spending the time with us. Thank you so much to Juan, all the way from Spain. And I think you really excited us with a fantastic presentation and demo with no technical hitches. So that's great.
Thank you. Thank you for giving me this opportunity to show my work. I'm very happy. Thank you.
Good. We're happy too. All right. Thanks, everyone. Enjoy your evening or morning if you're in the States.
Okay.
Bye.
Bye.